Class 7 Maths Chapter 3 Data Handling Animated Math Introduction. In previous classes you have learnt about data and also dealt with its collection, recording and presentation up to some extent. Now let us move forward step by step and learn more about data handling. Collection of data. Data. It means collection of information. Collection of data means gathering information regarding anything, like temperature of states of India, height of students of class 7, etc. Before collecting any sort of data, we must know for what purpose we are collecting it. Organization of data. Once data is collected, it has to be organized in tabular form so that it can be easily interpreted. Representative values. In our day-to-day life, we often come across a term called as average. For example, Ishan's average study time is about 4 hours. The average rate of samosa in my area is ₹5 per piece. The average attendance of students during exam is 95%. Now let us consider the first example. What do we understand from it? We understand that Ishan studies around about 4 hours daily. She may study for 3 hours one day and 5 hours the other day. Similarly, for other examples also, the values are not exactly same as the average values. They may be more or even less. But what we realize is that average is a number that represents or shows the central tendency of the group of data. Different forms of data need different forms of representatives or central values. One of these is arithmetic mean. Let us study about it now. Arithmetic mean. It is the most common representative value for a group of data. Let us try to understand it with the help of examples. Example 1. 2 vessels contain 20 liters and 60 liters of milk respectively. What is the amount that each vessel would have if both share milk equally? Solution. To find the solution for this question, we need to find the arithmetic mean. Mean is equal to total quantity of milk divided by number of vessels. That is, 20 plus 60 divided by 2 is equal to 40 liters. Thus, each vessel would have 40 liters of milk. From this, we get the formula for mean. Mean is equal to sum of all observations divided by number of observations. Now the question is, where does this arithmetic mean lie? Let's study the next subtopic range for it. Range. The difference between the highest observation and the lowest observation gives us range. It gives us the idea of the spread of the observations. Example 1. The age in years of 10 teachers of a school are 32, 41, 28, 54, 35, 26, 23, 33, 38 and 40. Question number 1. Find the range of the ages of the teachers. Question number 2. What is the mean age of these teachers? Solution. Step 1. Arrange the ages in ascending order. 23, 26, 28, 32, 33, 35, 38, 40, 41 and 54. Step 2. Range of the ages of the teachers is equal to 54 minus 23 years is equal to 31 years. Step 3. Mean is equal to 23 plus 26 plus 28 plus 32 plus 33 plus 35 plus 38 plus 40 plus 41 plus 54 divided by 10 is equal to 350 divided by 10, that is 35 years. Range of the ages of the teachers is 31 years. Mean age of these teachers is 35 years. Mode. For different requirements from a data, other measures of central tendencies are used. One such measure is mode. The mode of a set of observations is the observation which occurs most often. For example, if we ask 20 people about the color of umbrella which they use normally, it is but obvious that we get the answer as black. So black is the mode of observations. Let us see some more examples to understand mode. Example number 1. Find the mode of the given set of numbers. 1, 1, 2, 4, 3. 2, 1, 2, 2, 4. Solution. Step 1. arrange the numbers with same value together. 1, 1, 1, 2, 2, 2, 2, 3, 4. Step 2. Mode of this data is 2 because it occurs more frequently than other observations. Example 2. Find the mode of the numbers 2, 2, 2, 3, 3, 4, 5, 5, 5, 6, 6, and 8. Solution. Here, 2 and 5 both occur 3 times. Therefore, they both are modes of the data. Mode of large data. Putting the same observations together and counting them is not easy if the number of observations is large. In such cases, we tabulate the data using tally marks. The observation for which maximum number of tally marks appear is called the mode. Median. We now know that mean gives us average of all observations of the data and mode gives that observation which occurs most frequently. But in certain situations, both these measures of central tendency are not useful. For such situations, we need to find out the median. Now, what is median? Median refers to the value which lies in the middle of the data when arranged in increasing or decreasing order, with half of its observations above it and other half below it. Let us see some examples of median. Example 1. Find the median of the given data 24, 36, 46, 17, 18, 25, and 35. Solution. Step 1. Arrange the data in increasing order 17, 18, 24, 25, 35, 36, and 46. Step 2. Median is the middle observation, so find the middle observation. It is 25. It has 3 observations before it and 3 observations after it. Use of bar graphs with a different purpose. In Standard 6, we have studied how data can be represented visually in the form of bar graphs or pictograms. We have also studied how to interpret bar graphs. Now, let us study bar graphs in detail. The most important thing in any graph is choosing a scale. So let us start with it. Choosing a scale. We know that bar graph is a representation of data using bars of uniform width, but the length of the bars depends on the frequency and the scale which we have chosen. For example, in a bar graph where numbers in units are to be shown, the graph represents 1 unit length for one observation, and if it has to show numbers in tens or hundreds, 1 unit length can represent 10 or 100 observations. Let us study some more examples to make it more clear. Chance and probability. In our daily life, we often come across some statements such as, "There is no chance that it will rain today," or "Probably the test results will be declared today." In our life, there are certain things which may or may not happen. Chance. Sometimes it so happens that a student prepares 4 chapters out of 5 very well for a test, but a major question is asked from the chapter that she left unprepared. Everyone knows that the stronger team always wins in a game, but the day you bet in the stronger team, it loses. When we throw a dice, the chance that we get 6 is 1 out of 6. When we toss a coin, the chance that we get a head is 1 out of 2. In the above example, we can say that the probability of getting head is half. We can also say that when we throw a dice, the probability that we get any number from 1 to 6 is 1 by 6. In this way, chance and probability are related.